Here we go. Let's see. Testing microphone. I feel like I'm having microphone problems, so I'm going to test something out. 1 second here. There we go. Can you hear me? I see some folks are rolling in. Okay. Eleanor's here. Eleanor, can you hear me? I need to do a sound
I can
check.
hear you, yes.
Oh, great. Okay. You hear this?
I do.
Okay, that means my actual mic's working and not my MacBook mic. Okay, awesome.
And were we
Andrea live. What's that?
Were we expecting what was his name? Someone else, I think.
I don't know if we're expecting anybody. Just you and me, but we're live, so let's go.
Great.
You want to introduce yourself while I get started here?
Absolutely. I am Eleanor Millman. I am a VMware PM in VMware Tanzu. The areas I cover Valero, so I think lots about data protection, and I'm also the PM for Sonabui, which has brought me to this in the past, because Sonabui, I believe, is used to test networking connectivity. I don't know. So all that's to say is for all that I know Valero and Sonabui and could talk your ear off about data protection, I know far less about networking. And so Jay, I am so excited that you've agreed to let this be a beginner networking session. I'm bringing my networking beginner questions, so I'm ready to grill you when you're ready.
I mean, so I mean, I think we're all beginners, right? Like, so I forget this stuff every 2 weeks, and then I have to relearn it because of a customer escalation. So, but yeah. What's up, Vivek? And Vivek is here, and he's like a total networking expert, like a really hardcore one. Like he does.
Yes, he's already answered some questions I've asked, and I so appreciate his help.
Yeah.
Are you muted now?
Okay. I don't know. It automatically muted me. Okay, so I've spun up a GKE cluster. Antonin is here. Hi, Antonin. So we got the Andrea people here. We got some telco folks. So what I thought I might do, and we are expecting the our friend from AVI. So feel free to ping him. You're in that same channel, that upstream networking channel. GKE. External load balancing. So like, how do those work, right?
Is Bushan the
Bushan, yeah.
Bushan, yeah. So he needs the link. Can I send him?
Oh yeah, please send him the StreamYard link. Tell him I'm sorry for that.
That would be the problem.
Yeah. Okay. So here we go. So I'm going to connect. I just made a GKE cluster earlier, and this is not actually running Andrea. It's just running whatever the default CNI in GKE is. How do I do this? How do I open the running Cloud Shell? So I'm going to open a Cloud Shell up, and I'm going to go into it. And then, so while I do this, if the Andrea folks are in here, if there are any new Andrea announcements, now's a great time to let me know so we can sort of highlight those. So normally it's like happy hour for me, and I'm like drinking an IPA on this show, but I kind of partied out because I was in Miami for a week. So
whoa, that is truly adventurous.
So I'm just ready to get back to work and focus. So I want to thank you for asking me this question, Eleanor, because I had no idea what we were going to do on the show today. And I didn't have any ideas because I was in vacation brain. So if I go in here, for some reason, all my pods, what's up, Bushan?
Hey.
So the first thing I notice about this is every single one of my pods is pending. and I just made a GKE cluster just for random to see, and I wonder why all of these are pending.
To be clear, this is not part of the demo, right? This is a real life unexpected situation.
Yeah, no. This is totally like I just made this, and I assumed that I assumed that I would not have problems if I just made a cluster in Google Cloud. I mean, so kubectl describe pod. Let's see why these aren't up and running. But like as we're getting started here, we can sort of start to learn some things about networking. Like we can see here that in a standard, GKE cluster, we have kubedns running, and I saw that and I was kind of surprised because kubedns is like the older DNS and core DNS is like the new one that's pluggable. So, Bhushan, not to dump a totally random question on you, but do you have any idea why people still use kubedns? Is it better in some way than core DNS? That might not be your area.
No, sorry. Yeah, I don't think.
And can I ask? So you're saying, are these Kubernetes defaults, or are they? You're saying when someone how does someone decide between kubedns and core DNS? Like when they are on the Kubernetes cluster, they choose one or the other.
I mean, I think everybody runs core DNS nowadays. Okay. Anybody who's making a new cluster. Like if you started a new Tanzu cluster, you get core DNS, and it's configurable. So when you go into a Tanzu cluster,
I think it's what gets packaged. The upstream Kubernetes might still be packaging kubedns, and Tanzu does packages core DNS.
Okay. By the way, I can't actually read the words on your screen. It's too pixelated. I don't know if Bhushan has the same issue. Yeah, a bit bigger. Now we're getting there.
Here we go.
Thank you.
Okay. Oh God, and now it won't stop getting bigger. Here we go. Okay.
I find that very comfortable. Yeah.
Okay, here we go. Great. I gotta get this Windows stuff out of here. So did you deploy CNI? Yeah, I mean, I assumed that there's I just looked and it said no, it was a nodes issue, Vivek. So if I do kubectl get pods, let's just look at I don't know what I've got on here. This is a standard kind cluster. But this is an upstream cluster and I have core DNS running in here. And the thing with core DNS is if you do kubectl get cm-n kube system, you can say kubectl edit cm, and I can say core DNS-n kube system, and it has this really nice core file, and I can sort of really customize the way DNS works in my cluster. And it's like, the new DNS system that got put in place to sort of improve upon the configurability of sort of advanced DNS in pods and in Kubernetes clusters. So it's like, that's kind of the normal thing that I normally see, but in GKE, that's not the case. And maybe it's because they don't want you messing with with DNS in a GKE cluster because it's a SaaS, right? So anyways, this says there's no nodes. So now if I go in here and I there should be a way I can add nodes, right? So if I go in here, Chinchi, I'm back from PTO, Chinchi. So Vivek, did we deploy CNI? I'm GKE. I'm doing an autopilot GKE cluster, and I assume that GKE set up my CNI for me. But you're right, we may not have one. But so I should be able to node auto provisioning. It says it's enabled. Notifications, maintenance window. I've got all these notifications. Delete. Okay, I deleted those.
Just try kubectl get nodes and see if.
There's definitely no nodes.
Okay.
So if I do kubectl get nodes -o wide, no resources found. So I think I can make this cluster bigger by, how about this? I'm going to work on this, and then Eleanor, since Bhushan is here and he's like an AKO expert, how about you ask him a couple of those kind of questions about the application data path, right? I think one question Eleanor started with, which was a good one, I'll get us started, is so Bhushan, in general with AVI, right? If I create a service of type external type load service of type external load balancer, right? Yeah. a service of type load balancer, and it's an external load balancer. When I'm outside the cluster, right? So if I open my Myro board, where's Myro? Myro, I have this Myro app that I use now. So if I open a Myro board, and where is it? Yeah, let me sign in later. Try again. Here we go. Oh, it doesn't. Back to login. Sign in with Google. So if I'm a pod and I'm outside the cluster and I try to access weird. 1 second, let me open Myro in the browser.
Well, I can kind of. Oh, you want to keep? Oh, sorry. Never mind.
Well, yeah. So how does AVI manage the endpoints from an external load balancer perspective?
Sure.
And then feel free to add questions to that.
Can I actually translate into to show the level? Or actually, why don't you answer, and then I may have to ask you to go more basic. So, sure. Let's have that be the first question.
Sure.
Maybe let me share my screen. I have a couple of slides to
absolutely go ahead.
Show that actually.
Yeah. Even better, because then I can like do some weird stuff on my machine while you do that and try to solve the other problem I have. Scott's here.
Right. So
Scott, why are all my GKE pods pending? Have you ever seen this? I can't figure out how to scale my nodes up.
So Eleanor, do you see the slides?
I do not see your slides.
I still see Jay's screen.
I don't see your slides up yet. You need to like click the screen share button. Let me stop my share. And then you can go ahead.
I think I need to add permission to share my screen again.
Okay. Once you got that done, let me know, because that can take like a while. It's the whole Mac OS security thing. Okay, so so in here, normally I'll give you some. So are you familiar with the Coop proxy, Eleanor?
No. Coop proxy, did you say, or something else?
Yeah, Coop proxy.
What I know is that I know that Coop proxy is on every node and that it handles the networking bits.
Yeah, so normally in a normal cluster, and you don't see this, which is kind of the first interesting thing, and the reason you don't see this is because, well, I don't know why, but in a normal cluster, like a non-GKE cluster, you'll see that there's kubectl get pods -a. You'll see that there are these Coop proxy pods, right? And they, like you said, they run on every node, right? If I say kubectl logs, if I look at the logs for it, you'll see that it's kube system, right? You'll see that it's gone off and it's figured out what's node it's on, and it's using the IP tables version.
Does it use the DNS for that? How does it figure out which node it's... Actually, sorry, never mind. Keep going. So
it's a good question, right? Like, where does it go off and get the node IP from, right? Like we can, let's poke around and see, right? So tmux new -s, Eleanor, we'll name our tmux session after you.
What's tmux?
Tmux is a thing that allows you to have these two terminals, right? See that?
Oh, handy, very handy.
So, okay, so if I do find./-name node.go, right? And it's not even code that's inside of, it must be this, right? It must be this file that's doing that, right? So if I go in here, okay, so how does it do that? So it looks like what it's doing is inside of Kubernetes, there's a utility function called get node IP, and somebody's calling this. Let's see who's calling it. Right. Well, let's see what it does first, right? How does it get that? So the way that it's doing this is it's making a Kubernetes client and it's making a call to the API server, right? And then as soon as it calls the API server, it goes off to the API server and it says, I want to get the list of all nodes. Okay. So it's doing the equivalent of this, kubectl get nodes.
So let me just pause. I was expecting, we're talking about a kube proxy on a particular node. I was expecting it to somehow drill down into the node itself. And you're telling me it has to go all the way to the API server to figure out where it's sitting? Interesting.
Well,
okay, keep going.
Well, I mean, you're right. It is kind of a misleading message, right? Because it's like, it went off to retrieve its own node IP, right? It it's like we should add this. We should add this. Like, we should make a pull request, Eleanor, right? We should be like from API server, right? So that it's clear that like this isn't something where I made it's not doing this. Because I agree with you. It's like I would think maybe it would do something like this, right?
Right.
It would do something like this, right? Or whatever, it would do something like that and just grep that out, right? But no, it's going off to the API server. And then I guess the question I have is like, how does it, when it goes to the API server and it gets this node, like name? Oh, get node IP name. So it returns an IP for the node with the provided name. So somebody calls this.
It knows the name. So just to be clear, it knows the name of the node it's sitting on, but it doesn't know its IP. So it's asking the API server for the IP of the named node it's on, right?
Yeah, and I have no idea why it's asking that question. So if I do get grep get node IP, we can see who calls it. So this is interesting. Oh, and actually when the Coop proxy starts up, it actually, from its own host name, it takes its own host name. So if I do, this is turning into an interesting show. I mean, kubectl.
I'm having fun. This is great.
-n kubes. Hold on, kubectl get daemon set -n kube system, right? So we'll do kubectl edit ds-name kube proxy -n kube system. Okay. Right. And then let's go in here and then let's look, is this an argument? Like, am I telling it? Here it is. So, okay. So hostname override $node name. So this $node name thing is so somehow that is getting plumbed in. That hostname override. So one of the arguments to kube proxy is its own name when it starts up. So when you start kube proxy, in the instructions for installing a Kubernetes cluster, like, not that anybody has to read those anymore because we have so many great tools to do it for us, but like anybody who's doing this has to send this as an input. And then the kube proxy reads that.
But this part sounds surprising, right? Kube proxy needs to know the node it's sitting on. So that part, is that surprising? That seems to me normal to me.
I mean,
right?
I'm curious.
It's not normal. You know more than I do on this.
I mean, why does it need to know why does it need to know its own name? David, Scott, kube proxy is the best and David likes tmux. So I don't know. Like, I have no idea why. Yeah, like, so the question you're asking is, why does kube proxy need to know its own node name, right? So clearly it's calling it. So we could see. So
I
don't know what happened. Bouchon's having all sorts of, what's that?
But is the answer that it's somehow using that to query the API server to figure out its own IP address? I mean, but really my question is, why can't it just do that IP thing using IP just to get its, or whatever you use just to get its IP? To me, it's why the heck does it have to go to the API server?
Like, so, yeah, so like one question, I mean, you have two questions. Like, one question is, why does it need its own IP address? And I do know the answer to that. The other question is, why don't we just tell it its own IP address? Why do we want to give it a name so that it can figure out its IP address? Right? I mean, those are kind of the two questions or my version of your two questions.
Yes.
And
sure.
So one reason why I know that it might need its own IP address is because it's writing these low-level networking rules, and it has to make these decisions. So if I go and I say Docker PS, this is gonna work its way up into your original question. So, I don't know what happened to Bhushan. I feel kind of bad for him, seeing that his face is like grayed out at this point. So if I go in here and I do IP tables -save, it's going to show me all the networking IP tables rules that have been written on my system, right? We've gone through this a lot of times in this show.
And you're and you're on a particular node, a particular
yeah, I'm in a node, so
you're bigger. Okay.
I'm in a kind cluster, and I've just done a docker exec -t-i into this cluster, right?
Okay, thank you.
So if I go bin bash and I look at these nodes, IP tables -save, if I look at these rules, you can see if I say kube, well, this might be the smoking gun right here. What if I do kubectl get nodes -o wide, and I see this 172, and then I say like, well, do I need that? Crap. So it writes a rule specific to its own node. So it's going and it's saying, so there's at least one node specific rule that's been written.
What is that rule? Are you able to tell from that what the rule is saying?
Yeah, we can, but this doesn't look like it's actually a required input to the system. And the reason is because what this rule is saying is it's saying, for the Kubernetes, so every cluster that you ever get has a default Kubernetes service in it, right? So if I say kubectl get services, right, then there's a service called the Kubernetes service. And that service points me to it allows my pods, as soon as they come alive, to be able to ping Kubernetes and access the API server as like an internal thing, right? So, which is what, for people that are newer to Kubernetes, it's kind of a really interesting thing, because it's like being able to like reach up through your umbilical cord to your, to like talk to the mothership. It's weird, right? But it's really powerful, because now any pod can go query the entire cluster for other pods or other applications or other services or namespaces, right?
Mm-hmm.
And
why did you say that that's not a useful thing? I thought you were saying that
it's super useful.
No, you said that rule is not useful? Or
no, I meant to say it is useful. Gotcha. It's like the fundamental thing that makes Kubernetes different than Docker, right? Is the fact that there's this DNS, to me at least, right? There's this innate concept of DNS and cluster that's like queryable and manipulatable, right? From the containers that you create inside of the cluster. So discovery, right? It's the fundamental thing, I think. So I've got 1096.0.1 here, and I'm Kubernetes, and I'm saying this is a service, and this is a famous IP address, right? Like, this is the first IP address that's allocated when the Kubernetes comes online. It says, I'm going to make 1096.0.1 the start of my service IP ranges for new services. The first one, I'm going to make the internal one. And that's an internal Kubernetes thing. So Kubernetes makes that for you, right? So I bet we can even see it in our GKE cluster. So I can say kubectl get service. Maybe Scott can tell me why my GKE cluster has no nodes.
Now that cluster has a different IP, right?
Yeah, totally different.
No, sorry, yeah. Kubernetes. Oh, okay.
Totally different IP, but you can see that it also picked the first IP address in the range, right? 10.8.
Oh, sorry. Okay, I misunderstood what you're saying. So it's the .1 that should be the same for anytime I do this a get service. It should be
exactly.
.1 at the end.
Exactly. If I made another kubectl create service Bhushan is back, I think.
Can you guys hear me?
Now you're back. Yeah. Now, yes,
I was
sir.
stuck backstage.
Oh, sorry. I thought you were having all sorts of drama over there. I was like, let's just. Okay, so create service B. Why doesn't it like that? kubectl create. I thought I could. Oh, create service. I thought I could just create a generic cluster IP service.
You need to give a whole YAML.
Oh.
Service.
kubectl create service example. Let me just grab a regular YAML service from somewhere. I have this. I know I have all my examples that I use are here. So if folks want to follow the examples that I use on this show, you can go to JUnit 100 K8s prototypes tree, and I have like all these stupid examples that you can use. So here's one of them. Here's one of the ones that I always use, 4 of us. And it creates a whole bunch of pods that you can smoke test your networking. So let me wget this onto this, and I'll create this. And then what we'll see when I do this, right, is we'll see that we'll have new services, and they'll have kubectl create -f 4 of us. Okay. kubectl get service -a. So let's get all the services now. So now we can see, like, we have all these services, right? So we have the first one, though, is 10.8.56.1. And then we have these other services, like I just made, default HTTP backend. That's .57.253, and the other one's .56.10, and the other one's .57.92. And so, like, there's all these new services being used, but the first thing in that whole range is that, and that's done by the on startup. There's a the API server. It's such a fundamental thing to Kubernetes. The API server sort of goes off and makes that IP and reserves it as the internal cluster IP. And then in this IP tables rule, what's happening is it's saying, look, I need to write a rule so that if somebody hits this node and they're trying to go to, this, they're trying to go to, yeah, I see. Okay, so if this is saying if it's the source, if the source is me, 172.18.0.2, then I need to do some masquerading of the traffic or whatever, right? And then this is saying if somebody by TCP is trying to access the internal Kubernetes service, then I'm going to write a destination natting rule, so that I'm going to write a rule that says your new destination is 172.18.0.2. So anybody who's trying to access this service, right, is going to like sort of get sent to the API server that's running on this node, and this is the node's IP address. So if I say kubectl get nodes -o wide, right, this is the node's IP address. So these rules are written by the kube proxy. And so this is kind of relevant to your original question of like, how does this external traffic work? Well, external traffic still requires on the kube proxy, even if you have something like AVI, right? Now, Bhushan, maybe you can share your screen and show that.
I actually apologize. I have to drop in 2 minutes, but
you've
already answered some questions. Thank you.
Yeah, we can talk about it more like later. So yeah.
I'd be delighted to.
Cool. So ping me offline, Eleanor. Yeah.
Can you allow my screen share?
Yeah, sure. Or actually, we'll just go through this on the rest of the show, and you can just watch the last 30 minutes later on after you're done working.
Exactly.
Okay. Now I can see your screen, Bhushan.
Okay.
All right.
So, yep. Here are the slides that I was talking about. So, as Ajay was saying, right, each node has its own kube proxy running inside, which takes in the traffic. So usually when you expose a service out to an external client using either NodePort or a Loadbalancer type service, it internally creates a NodePort. Even when you create a Loadbalancer type service, it creates a NodePort for it. So the service is basically listening on the node's IP address, some port. So that port will be the same across all the nodes, but the node's IP address will be different depending on what node it's on. So just ignore the service engine for now, the AVI service engine out here. If a external client wants to reach the service, you can directly browse to the node's IP address : the port, and that way the traffic will reach the node. And on the node, the kube proxy IP table rules will see that this incoming traffic is coming on this port, so I need to send it to the application pod. So it will make the last hop decision of sending it, and it can send it to a pod on the same node, or it can send it to a pod on a different node. And this is where the external traffic policy comes in. If you set it to local, it will only send it to the local node, the pod on the local node.
So you must have node ports working for AVI to work.
No, this is one of the way it works. This is the way most of your layer 4 load balancers work. But with AVI, we have an interesting way of bypassing the kube proxy altogether. So if you do kubectl get nodes -o YAML, right, you will see for every node there is a mapping between what the pod network is allocated to this node. So each node will have a /24. You can change it, but by default, it's usually a /24 network allocated to every node within your cluster. And AKO is a operator that AVI uses for integration with Kubernetes. So it syncs all of these from Kubernetes API server and then programs static routes on AVI. So it will say that in order to reach a pod in this network, your next stop is this node. So that once the service engine knows all of these static routes, whenever it needs to load balance to any pod inside the in your cluster, what it will do is it will send out a packet with the source IP of its own interface. The destination IP will be of that of the pod. The source MAC will be of the service engine, and the destination MAC will be of that of the node. So what happens is since the service engine is on the same L2 network, the packet flows to the node, and once it's on the node, the internal OS networking sees that the destination IP is actually the pod's IP address, so it routes it to the destination pod. So that way, the service engine can directly reach the backend node.
So Avi is writing routing rules on the node.
Not on the node. It's writing on the load balancing.
I'm sorry, yeah, on the load balancer, and then the
And this
Okay.
is how even GKE works. So GKE has two modes. First is the routed mode, where GKE also learns about these routes and programs them in GKE networking. And the second is the VPC mode. VPC mode is completely different. It basically exposes these pod CIDRs into Google's network itself. So the pods become routable that way. But yeah, the older way GKE used to do is the same way that AVI does. So it even there they sync the routing tables.
Okay, so the route, but that next hop is because I got distracted and I was answering and I was doing something else. So you were saying though that the next hop is let me make my screen bigger so I could see your screen a little better. There we go. Okay, so oh yeah, that's better. So I come in and I'm a user and I want to access my app, and my app has a VIP of 10.10.1.100.
Yes.
And inside of my cluster, my pod's IP address is 192.168.10.100, right?
Yep.
And the way that I get to 192.168.10.100 is Avi writes a route, but Avi's outside of my cluster.
That's true. Yeah. So for the client doesn't care which pod it gets routed to, right?
No.
The client's TCP connection ends at the VIP. Once the service engine gets the request from the client, it opens up another TCP connection on the backend side.
But doesn't that change the semantics of some of the expectations from the client's end? Because isn't there a thing where you want this is almost like a user space proxy.
This is how any proxy you use, any L4 proxy you use will do. Even in the case of other proxies, usually use NodePorts. If you use ELB and all, it uses NodePort on Kubernetes cluster. So in Amazon.
So you make a new, but you make a new TCP connection.
Yeah, basically the service engine or any load balancer does that's sitting in line. It does a source NAT. So your pods will see all the traffic coming from the service engine side.
So my pod that's running in the cluster, what IP does it see is the question I have.
The service engines or the load balancers interface IP address.
Okay, so you don't preserve the...
We can. That's another feature that we can do. So we cannot directly have preserve the client IP on layer 3 packet because we want the return to go through the service engine. If we preserve the IP, then the pod will directly answer to the client, and there is no direct TCP connection between the client and the pod, so that will fail. So there is a source netting happening out here, but if you want still to preserve the client IP address, you can use layer 7 features like X forwarded for header, in which we insert your client's IP address as a header field in the HTTP request.
Because
Or
the reason I'm wondering about this is check out this issue that I just put in the notes. Do you see that? Because we were just working on this, and this is a tricky thing, right? Oh, sorry about that. I just screwed your whole.
no, that's fine. I think I stopped. I couldn't see their notes.
So it's tricky. How about I share and I'll show you something.
Yeah.
So if you look at the Kubernetes documentation, it says the source IP for services with type. And so we had to read through this once. It was with Anusha. I had to read through this because we're working on this in KPNG. And we ran into this bug where there's this one test that fails. And it's 162, right? And the reason it fails is because there's a test in Kubernetes itself that confirms that you always preserve the source pod IP for traffic through the service cluster IP.
Yeah, this is cluster IP type service, right? We were talking about Loadbalancer type service. So cluster IPs are all internal to the cluster. So they are unique to.
Okay, so this is only for. This doesn't apply for. Yeah, you're right.
Yeah, not for the external.
Good. I'm getting my service types confused. And so this is only for cluster IPs, but for node ports, that's not a requirement. We don't have to preserve the source pod IP. That makes sense.
Yeah.
Now this all makes perfect sense to me. Okay. Cool. Okay, cool. So you can share again and keep talking through your data path.
Yeah, let me do that again. Okay. Can you see this, or can you see my slides now?
No. That's weird. Did you get that?
Oh, okay. No, let me try.
There it is. Yeah, now I got it.
Okay.
Yeah, now you're back. Okay, cool. So go ahead and start over. Yeah.
Yeah.
Or start wherever you were. Yeah.
Yeah. So we talked about NodePort, how that works, how AVI does direct routing to the pods. So most of the CNIs, whether you use Calico, Flannel, Antria, Canal, all of those don't expose the pods as a routable entity outside the cluster. So you need this kind of a mechanism to directly reach the pod in that case. There are other CNIs like EKS uses AWS CNI, and that makes the pods routable directly. So in that case, any load balancer or any external client can directly ping the pod or directly reach the pod without any source netting or any kind of routing required. Routing is built into the networking of the stack. So even NSXT CNI does the same. If you're using clusters over NSXT overlays, you can have your pods routable using NSXT CNI. But for without those routable CNIs, right? You are stuck with only two options: either NodePort or ClusterIP mode that comes with AVI. And each of them has their own pros and cons. So say if you are going with NodePort mode, you do not have the ability to select which pod you are going to. You're at the mercy of the Kubernetes proxy. So wherever the Kubernetes proxy sends you, you have to go there. So you cannot persist your request to a certain pod on the backend side. So if you have a stateful application, that cannot be done using this kind of a method. This is solved by ClusterIP mode because we can directly talk to the pod and we can persist the request to the same pod.
But you can do session affinity with Kubernetes proxy, right?
Yeah, there are other ways to get around it too, but what you call it.
But Avi's still better.
Yeah. No, so when you think about NodePort, right? NodePort is exposing the service outside. It's not exposing the pods. So when you health monitor any load balancer which health monitors a NodePort type service,
Yeah.
it's checking if the service is up. It doesn't check if the individual pods behind the service is up.
So wait, Scott has a question. Does Avi support ClusterIP mode with routable pods, allowing then for the reuse of SEGs?
Yeah, it does. Yes.
Okay.
It's very AVI specific questions for our other viewers who are
Well,
listening to this.
Scott's a pretty hardcore VMware Avi guy. So yeah.
So
Vivek, I saw you join. Did you have anything specific, or you just wanted to hang out with us? I'm really glad you came, by the way.
Just hanging out. I just got the link now.
Cool. All right. Yeah. So feel free to interject at any time. Okay. All right. Go on. Doug, what's up? Hey. Where were we, Bhushan? So you were just saying.
I was talking about the pros and cons of these two methods. Like I said, the persistence breaks down when we don't have the power of deciding which pod to choose when we are doing load balancing. Mm-hmm. Also, we cannot do health monitor all the way to the pods because we are actually health monitoring the service that is being exposed. Those are solved by ClusterIP. Since we can directly reach the pod, we can even health monitor the pod level. But with AVI, this requires a separate SE group per cluster.
Now you.
Yeah. Good.
One really quick question: does Avi support egress stuff too, or do you use it for that, or it's only an ingress thing?
Just an ingress thing.
Okay. Cool.
Just layer 4 load balancing and ingress and routes for OpenShift.
Okay. Cool. Yeah. Got it. All right.
So.
All right. Have people asked or customers asked to like make it some kind of a choke point thing for that? Because I've heard about that a lot lately.
Yeah, we did have we did try out being an egress proxy also, but that project got stalled right now. So right now we do not have to bring it back on our roadmap yet. And we do have customer asked to do egress, but most of the customers who are also exploring Istio, and Istio has a really good egress way to not just egress but even network policies to tie around it.
This is a big thing. So it came up at SIG Network the other day, this idea of people want maybe a network policy that says I can only access things through this IP and things can only come in through this IP, and nobody knows where that should live and nobody knows who should own it. That's why I was asking that.
Yep.
And Antria does support egress IPs, and JuneGen wanted me to show that today, but I have vacation brain and I didn't have time to but I think we talked about that a little and at some point because it came out a while ago, and we definitely need to do a demo of it. It's a big thing, right? People want, to do stuff like where all the pods going out, traffic out of the cluster shows up from a well-known IP range, and so
One more thing, right? You guys also need to consider VRFs. This is not something that you might see from too many enterprise accounts.
What's a VRF?
It's an isolated network.
Yeah, you have multiple isolated networks in your. They segment your.
Why did you both laugh at me when I said that? Is it a dumb question?
No, we were just laughing because we are going through the pain.
Oh, okay. There's some inside joke. Okay. There's some nerd inside joke thing going on with VRFs that I don't get.
Why I was saying that is, right, so some of the customers, they segregate their network into multiple isolated ones, and each one in theory can have their own subnet, and it can be overlapping, non-overlapping. So the problem we are facing is, say you have pods which are running, and one pod is a part of the VRF1, say, right, the isolated network 1, and there are some pods which need to communicate only with other pods which are in VRF2, right? Now we also need to, so one thing is how to make sure that You send out the packet with the correct source IP, which belongs to that particular VRF. But the second thing is also from the routing side as to how do you decide the packet has to go to VRF1 or to the VRF2 to decide the destination, right? How do you decide it?
Can we pull up a visual for this? Like if I do VRF, if I Google for it, let me
Probably
see.
you can set up a separate session for that, Jay, if you want.
Okay.
It's a bit more complicated one. I don't have a solution. I was working with the NSX folks when they were doing some routable pod. I was working with a PM where we wanted to also introduce some kind of a VRF ID. They were trying to do something. I can try to work with the Andrea folks to see.
What's this? Is this a VRF?
Yeah.
Voice VRF, or is that?
Yeah, so
something
you have
different?
separate networks, right? If you see green is one network and red is another network, and probably orange is different network, and they want to isolate all the traffic, right? They don't want the people in the green network to see the traffic in the orange network.
Ah, yeah, okay.
Some sort of security.
The voice people and the data people. Yeah,
They don't
okay.
want to see each other. Meaning
Finance and
yeah.
sales, they don't want to talk to each other. Yeah.
So
Okay.
so we need to also consider how do we make sure that these kind of communication is supported by Kubernetes. Because if I understand correctly, the fundamental construct in Kubernetes is there's only one network which it uses generally to talk to outside world, right? And inside the network, it's like all pods can talk to each other.
So
How do
I
we-
wonder if has somebody filed an issue and it has like 4,000 comments of people fighting about it upstream. Oh, 3 closed issues. Kubernetes supporting.
And can you go to the last one? I want to think my name is. Can you go down?
Were you fighting? You're the one. You're fighting with everybody. Why did you close this?
I didn't close it. Somebody else closed it. So I was
Yeah, who closed it? What would like to be added? The net dev topology, ETH0, ETH1. Yeah, who closed it and why? I don't see anyone closing it.
opened way before I tried to talk to them, and so yeah,
So
it was closed by the author. Yeah.
So if I go in our documentation site, like, do we need to, we should file an issue, right? Kubernetes docs, GitHub. So we should file an issue and we should assign it to SIG network of the 500 issues that we have, right? VRF.
And
Well-
you remember, Jay, when we were talking about multi-secondary interfaces? That sort
Yeah.
of helps this. So what some people do is the easy way out is add secondary interfaces into your pods, and each of those interfaces connect to one of these networks if needed.
Yeah, and that's why you do the multi stuff.
Yes, but if you want to take it in a, so probably Bhushan can help you saying what are the VRF constructs available on the AVI side. If you want to do it everything over the primary network, you want to use a single primary network to support multiple.
Oh, and this is like a thing. I didn't know I could do this. So I can do this. IP, I didn't know I could do this. So I can just do this in an IP VRF show. It's like a normal command you can run on any Linux node. Okay. Cool. And OpenShift seems to basically be saying, is this what OpenShift is doing? Are they doing multis here? I see they've got this Mac
there is
VLAN.
a plugin on upstream CNI to support VRFs. If you go
Okay.
to CNI.dev, there is a plugin to support it for multis, but there is no way we can handle this via native Kubernetes construct. At least I haven't seen any proper way. in which
So you create a pod. The pod has its own NIC that's off of the regular Kubernetes network, and then you can make that data path for that particular pod in the cluster follow something, but you can't use services with that pod.
Exactly, right? You cannot use services or leverage AVI for now, right? Because they are going to be secondary interfaces.
Kubernetes pods with VRFs can't use AVI.
So there is a cool thing that they are doing. Jay, you remember once Doug joined us when I was also giving the session from Red Hat? You know the guy who was coming in and was Doug Smith.
Yeah.
So they are working in the Kubernetes networking group on a project called Multus Service. You can Google it if you want. Hopefully you get it. So they are trying to come up with a thing where they can provide some sort of services for secondary interfaces.
That's the networking team over at Red Hat, our friends.
Yes, but still that will cover the incoming, but we still need to worry about outgoing if you want to do it native. But there are some work being done here. So
Yeah.
for people who are interested, they can join the signaling networking group, and there they are talking about it, about the supporting.
Where do people get involved with this? Is there an upstream group for this?
Yeah, the Kubernetes networking signaling group, right?
Networking
I can,
signaling. What's that?
I can ping you the thing.
Network plumbing, I think you're talking about.
Yeah, network plumbing group. Yeah.
And there's also the CNI group that meets every Wednesday morning at 10:30.
We
And
used to attend. You remember? Yeah.
yeah, we used to go. I got lazy, but if anybody wants to go, let me know. I have an invitation to it. I'm happy to send it along. You can ping me on Kubernetes Slack. Vivek also has one. You can ping him. So, okay, cool. So let's
Yeah, but
put a little.
VRF is also an important thing. I don't know if it's as applicable on the enterprise side, but coming from the telco background, again, as Jay usually puts me in, there is a lot more emphasis on supporting.
Yeah.
VRFs are usually is basically a remnant of the legacy networking that people used to do on hardware routers. Now with overlays and all, we don't usually come across that a lot unless it's it's still in setup where environment where people use legacy networking, like in telco use cases and all. So
Yeah. Okay. Sorry, Vivek. Maybe that's the answer to your question.
I know. We are old folks.
So yeah.
we still need hardware, right? Even though we
Docs
can do
too.
things in software.
About services, about why VRFs are not supported. And like, so we should probably, I don't think this is a bug report, but right now, some folks are interested in multiple services that are on different pods. On pods that are on different service networks, I guess is what you're saying, right? In the same,
Pods which have, which are connected to different VRFs. Yeah.
like you want orthogonal, yeah.
Yeah.
Add a doc page explaining why this isn't a part of the K8s service model. Maybe it's not even possible because of the data model for service siders. I don't know. Not sure. I think there are fundamental changes in Kubernetes services that would need to happen API to really properly support this. Like you would need maybe to add, I don't know, /
Kubernetes does support custom resource definitions, right? So anything that can't be directly supported on traditional services can be done using CRDs.
And I think the page we should update would be tutorials. And not tutorials, it should be like services. Like, let's see, what page would we update here? Service. Like, service. Like, it's like we would want a page like services networking, and we might say like legacy services apps or something like that. No offense, Vivek, but can blame Bhushan for that. Okay. So let's submit this, and if anybody wants to work on this, this is a good first issue. Good first issue. Cool. So, and then I'm going to reference your VRF issue that you were complaining. I think this is hilarious that you're the only person that complained about it.
So I
Okay.
also pinged one chat here. I don't know how to do it public. That has the work that they are doing on the network plumbing group to support secondary interfaces to be exposed as a service. So I was about to reach out to Bhushan about it to support it in RV2. So
Oh, okay. Well, here we go. Here's your chance.
to modernize.
Yeah. Cool. Let me add these notes with these links here. And then, there's no reason why I can't actually just add the page link. We discussed this on Antria Live this week for the full discussion. Link is at, and I can just literally add the link right now, right? So I can, what is the link to it? Let me see here. Antria Live, YouTube. Let me grab that link. Where is it? 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 Where is it?
And again, to taunt AVI's support, sorry, Bhushan, I'm taking your space. AVI does support VRF constructs, but it's like the entire Kubernetes cluster has to belong to just a single VRF, right, if I'm not wrong.
Yeah.
Right, Bhushan?
Yeah, that's
Yeah.
right.
So AVI does support VRF. It still supports some legacy applications where they want to run or they want to support multiple VRF. They can do it at a cluster-wide level, not a service level. It has to be for the entire cluster.
So you would have a VRF. So how would that work? So you would have so in that situation, if I had a VRF in AVI, how does that work? I have AVI here.
Yeah.
And when you say a cluster, do you mean like a bare metal cluster? Is that what you're talking about?
Even if it's a VM cluster, that's fine too.
I mean, but it's not a Kubernetes thing.
No, VRF is not a Kubernetes thing. It's a networking. Yeah, it's a networking construct. Basically, what VRF does is it breaks a router into parts. One makes two router out of one. So AVI does support that, but what AVI does not support is bridging across VRFs. So since Kubernetes has only Kubernetes by default, it doesn't support VRFs, right? So it's only one network on the backend side for AVI, and if you have multiple VIPs on the front end into multiple VRFs, that won't work because we don't bridge across VRFs. So
okay.
VRF does not directly work with AVI in Kubernetes, but we have other ways to get around it.
Like what?
So in telco use cases, we use BGP to advertise VIPs into certain selected VRFs. So everything on Kubernetes side is in a single VRF, but once it comes to AVI makes a decision of where this VIP will be advertised to. So say VIP 1 for application 1 is sent to VRF 1, VIP 2 for application 2 is sent to VRF 3, and so on.
Okay, so this is VIP 1, and this is VIP 2. Okay, cool. So AVI has a way to do this, and AVI becomes application aware because you manually program. When my application starts up, how does my application get put on the thing? How does app 1 get put on this green network?
There are some CRDs which says from which network you want a VIP, right?
Yes.
And then there are also knobs there to say when you allocate a VIP from this, it's like an IP pool, right?
So you put an AVI CRD on a pod, and then I can have that.
You
pod.
annotate it. Yeah, you reference that CRD.
You put an annotation, and that, and now that pod, when it comes up, it's associated with some kind of CRD that then AVI says any traffic coming from the IP, this IP address, I'm going to put it in the green pipe.
Yep.
I didn't know you could do that.
No, you're taking it the other way. So it's the service which is annotated because it's a service which needs to be exposed. And so for that service VIP is then going to be only advertised to certain peers. Again, these are all controlled using some knobs. So you use kind of, again, some label which you use to match between the value you have in CRT and the value they have in the AVI controller to say this VIP has to be advertised to certain peers, right? And it can be propagated upstream in that particular network. But this is, again, only handle the incoming request. So that's why when you guys were talking about egress, I wanted to bring it in that there is no native way to handle VRFs now in egress, right? Because when this pod wants to send out a request, we don't have an easy way to send it to the correct network. AVI helps us on the incoming side, but since AVI cannot do the egress, there is no easy solution for this. We are doing some hack on the NSX. If you guys want, I can explain to you in some other session where we do some sort of source netting.
So this whole diagram is backwards because that's not how. So I got it backwards. It's actually
No, it's actually good for how advertisement works, the BGP advertisement, but the packet is the reverse. Yeah,
yeah. It's really like
the
I'm
packet goes the inverse. Yeah.
okay. I'm a user and I want to access this service, and then this service is going to send me through this network. But if I'm a user and I want to access this other service, it's going to send me through this other network to here.
No, there is only one network
One
between
network.
the RVSCs and the networking, right? As Bhushan is saying, there's no concept of multiple networks at the Kubernetes space, right? So there are only single interfaces on your Kubernetes nodes.
Yeah.
So there are only multiple interfaces between the end user or the client and the RVSCs.
Okay.
So the different colors will be only between the client and the SEs, and from
Between
the
the
SEs to
SEs and the VMs, it's a single interface. Yeah.
Let me get rid of these arrows. I don't like these arrows. Okay. From a user perspective, the user doesn't really know that these are VRFs, right? So they go to some IP that Avi is taking care of, right?
yeah.
And then Avi's going to say, I see what you're trying to do because there's going to be an annotation. And then Avi's capable of going here, but then there's another service here, and that service corresponds to another application.
Mhm.
And then Avi will send me to my red app. And in this networking model, I've got an app here that's running on my node. And when I do this, there's no way that. So like, what am I preventing here? If I'm accessing everything through Avi, what's the point of all this? Like,
No,
This-
you got it wrong. Again, between
Yeah.
the second red line that you drew between the RVSE and the red app, that also needs to be green. It's the same green network.
this needs to be green.
Yep. Because there's only one interface, right, on your VM. There's only one interface or network for the Kubernetes to export
Okay.
outside. So it's still green, but it's at the RV where your blue and red gets differentiated, right? I assume your blue is your app 1's VRF and red is app 2's VRF.
Okay, so what does that buy me?
You're going to support multiple different VRFs, right? So your app 1 is exposed only to your blue network, like how you saw in that initial diagram, right? So say that is your your finance.
So
They can access app 1, and if it's sales, which is your red app, they can access app 2. The sales people cannot access app 1 because the VIP belonging to app 1 will not be advertised in the red network. It will only be advertised in the blue network.
So Avi's aware of.
basically, you get to VIP level isolation. A client in VRF1 can only access the VIP in VRF1, not VIP in VRF2. Even though both VIPs are sitting on the same AVI,
A client in VIP1,
VRF1.
in
VRF.
VRF. Okay. So there's a red, in other words, there's a red person we haven't talked about here.
Yeah.
And he's going to be sending traffic here, and Avi's capable
No,
of.
it will not be over blue. It will be over red network. They are separate networks there.
Oh, yeah. Okay. Now this is making sense to me. No wonder why Scott hates VRFs. So, okay. Here we go.
You have to
And
live
they-
with it. You have to live with it.
So, really, the whole use case is that there's somebody who's already only in the red network,
Yeah.
and he or she can do this and then get forwarded here. And then there's somebody else
The
who's-
blue network. Yeah.
who's in, Mr. Blue and
Mr. Red.
Mr. Blue and Mr. Red. Yeah, here we go. So we've got,
No, it needs to be blue because green is a different network. You use it between your RVSCs and your
I
Kubernetes.
thought I got rid of all my
Right.
blue.
Yep.
So this blue person is allowed to access green services.
All
You can see
services
like
are.
that. Yeah, the app 1, right? If you want, you can rewrite your app 1 and app 2 in blue and red if you want.
This should be blue.
Yep.
and this should be red.
You got it.
You should have told me this a long time ago, Vivek. You should.
Now it looks good. Yeah.
Okay. Okay, cool. So that's what we're doing. Got it.
Yeah.
Okay. So we've gone off and done this is interesting. So, I think we answered Eleanor's original question. But I want to do a general, and I don't know if we have a diagram. I think we do have a diagram in here, and I think we can just sort of show it to folks because so this was supposed to be an introductory session, but it got really interesting. So let's go back to the original thing that like what happens when a person normally accesses a service. And well, since Bhushan is here, we'll replace this with AVI. Actually, this is a layer 7 example. So, AVI does layer 7, right?
Yeah.
Yeah.
It is.
AVI's not just VIPs. AVI does layer 7, so we can call this AVI, right? So, normally if you make a service, so this is for you, Eleanor, even though you're not here. I went through this with Matt Fenwick once. I don't know if Matt's here, but so normally you might make a service if you're a user, and then after you make that service has a status associated with it. Okay. And if that service, has load balancer ingress rules, right? Then if you look in there, these are associated with ports, and we're still in the services world, right? Mm-hmm. And so I can see this, so I can go over here and I can kubectl get service -o -a. And I can kubectl edit service kube dns-n kube system, and I can look at the whole thing, and I can see it has a spec and a status, and there's no load balancer because it's not a service of type load balancer. It's just a very simple ClusterIP service.
Yeah.
But in any case, if you're making a service of type load balancer, then you'll have this status in here, and this status at some point will get filled up by your cloud provider, right? Your cloud provider, in Avi's case, Avi does this, right? Like Avi goes and it writes this information. And then so Avi literally goes in here and it literally goes and it starts adding stuff here. It'll add an IP, blah, 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 blah. It'll add all that. And after Avi does all that, then when you do kubectl get service -o wide, you'll see the IP address of that service. And then Bhushan's original part where you have that service and then that service forwards traffic down to the pods, that stuff happens, and that's controlled by your cloud provider, right? And so then Avi will then go off and it will send things to the endpoints, which are conveniently down here because of a different diagram we were drawing at a different time. But ultimately, it will then send things to the endpoints of the services. So if I say kubectl get endpoints -o wide -a, you'll see that this same Kubernetes DNS service here has a list of endpoints. And so if I say kubectl edit endpoints, well, we should have done endpoint slices, right?
Yes.
So forget about endpoints. We should be talking about kubectl get endpoint slices, right? And if I say kubectl edit endpoint slices Kubernetes, right? If I go in here, then I'll see that I have a list of addresses. This is an optimization. So endpoint slices are an optimization that they put in to make it easier to do large scale networks. But so this has an endpoint, right? 172.18.0.1. And we can see IP tables -save. We ran it over here. That endpoint, this IP tables rules is written by Coop Proxy, and it's saying that this destination here, it's saying people who want to go to this service endpoint will get destination added to this IP address, right? So that's the way that the traffic works, like from an end user perspective, right? Is that ultimately your endpoint slices get, like, there's load balancer logic that gets programmed by your load balancer to send you to the right place when you hit nodes. And
Only one thing with the cluster IP mode that we talked about with AVI, these IP table rules do not come into picture at all. The service engine, because of the static routes, it will directly send it to the pod.
yeah, with Avi, what is the name of this feature?
Cluster IP feature. I know it doesn't map to the actual name of the service, but
Cluster IP feature. Then let's see. Is there a doc page about that? Avi.
yeah, we have a GitHub.
Avi. Why that does? Oh, I spelled it wrong, and it gave me a bunch of weird results.
Search for AKO. It will give you better.
Is this it? That's
No,
different.
that's a different one. Let me give it to you.
This one?
Yep, that's the AKO page.
Here it is.
Should be somewhere in there. Yeah.
The section covers great. Okay. So in Azure,
Yeah, Azure
Similar to-
needs some extra networking things to be done because of the way their networks and routing work.
okay. But overall, the highlight, the way you define it is, you never really say what cluster IP mode is, though, do you?
I think we do it in the explanation values.yaml.
Oh yeah. Okay. So if I go to Avi Helm charts, you mean
Yeah,
I
it's
go-
on the same repo.
values.yaml? Where's that?
No, they don't give the actual Helm chart here. You have to just check the documentation. This is just a documentation side.
Ah, okay.
Yeah, maybe let me give this to you. Values.mt.
Here we go. I got it.
This is the actual values.ml from the Helm chart. Maybe open this one. I just sent it on private chat.
Okay. Here we go. This is only used in cluster IP deployment of AKO and in vCenter Cloud, and only when disable static route sync is set to false. Oh, sorry, I'm at the wrong.
Yeah. Search for service type. L7 setting service type.
This option specifies whether AKO functions in cluster IP mode or NodePort mode. By default, it's set to cluster IP. Allowed values are cluster IP, NodePort. If the CNI type is for Antria, then another service type called NodePortLocal is allowed. So this is for an individual service.
No, so this is a global setting for.
It's a global
all-
setting.
Yeah.
Oh, okay.
So basically, it manages the way the service engines will reach the backend.
So in other words, it will basically always use NodePortLocal for anything.
No, NodePortLocal is a feature only in Antria. We haven't added it to other CNIs yet. So
Default is cluster IP.
default.
But
is
it's
cluster
saying,
IP.
if you're using Antria, then another type is NodePortLocal. So if
Is
I turn NodePortLocal on, what's that?
That's allowed, but that's not turned on by default.
It's not by default. But in that case, it
Yeah.
will use NodePortLocal for any external
That's right.
connectivity. Yeah. By default, set to cluster IP. And then does it say when to use NodePort versus cluster IP in here?
No, it doesn't say it out there, but that's a bigger conversation regarding how the service engine and Avi's licensing and all works.
Ah, okay. That's more of a, okay, cool. So it's a licensing question. So in general, you always would want to use cluster IP though, right?
Yeah, that's a better thing to do.
In general, you'd always want to use cluster IP.
Yeah.
And then you still need Coop proxy on your cluster because you still need certain things for egress and so on and so forth, right?
Yeah. For
Like,
egress,
you still need Kubernetes proxy. It's just that for all your external services, you don't need Kubernetes proxy anymore.
that's correct. Yep.
Cool. I didn't know that. I learned a lot today. Cool. Well, thanks for showing me all this. So we were supposed to be showing Eleanor a bunch of stuff, but instead you got to show me a bunch of stuff. But anyways, I'll sync up with Eleanor later and help her talk through some of the other issues she had. But thanks for coming, Vivek, and Bhushan. This is great. And let me get rid of this comment here. And thank you, everybody. If you are enjoying the show and you're learning stuff every week, please do like and subscribe so we can get the entry. Keep all of our upstream content justified to our management chain, so we can keep doing it every week and not working. So, all right. Thanks, everybody.
All right.
Thank you.
Bye, everyone.